We say astronomicals because we are not renewing the sun. Nobody is renewing geothermal energy. Nobody is renewing tidal power from the moon. All of these are very large forces mobilized at an astronomical scale to do. Wind is powered by the sun, in fact. The sun is powered by the sun. Tidal by the moon. And geothermal by the Earth's molten mantle around the core, losing heat to space and being intrinsically radioactive. These are astronomical forces, ladies and gentlemen, which unleash an enormous amount of power in a very diffuse manner. The power in a hurricane is bigger than that of Hiroshima. The question is, how do you harness it? It's expanded over large areas, and therefore, if you are going to do things in renewables, scale is beautiful, not small is beautiful. You have to have a very large installation of wind or solar power for it to make sense, given the diffuseness of the energy involved. So what we find is, in fact, that with this new and very difficult source of power, and photovoltaics also very difficult, it's 10 years really before some solar panels become probably the economic equivalent of coal or gas. It's in fact the Chinese, along with Sharp and some other manufacturers, were leading the way. Now here's the CEO of Suntech, looking a bit like the sun himself, rather like. And here's what they're doing it at scale with what are called building integrated photovoltaics. When you do all of that, not just on your own little suburban English roof, but across a whole factory or a whole office complex, then you are delivering a bit more than 1 megawatt. Anything less than 1 megawatt is toy town, really. Even 1 megawatt is toy town. But 10 or 100 or 1,000 now we're talking, and this is probably generating between 10 and 100. So it's not Britain that has the technological leadership, or will get it anytime soon. The focus for innovation, the initiative for innovation, has already shifted east. So why has that happened? Well, we've got to understand some of the scale of the problem first, before we turn to the why. Here we have a kind of national equivalent of research intensity, which is the general expenditure on research and development that business does as a percentage of GDP. You'll see the EU is futting along at 1% of GDP. The OECD area is 1.5%, the United States is stagnant, under 2%, and Japan has been rising in terms of GDP as a percentage of, R&D as a percentage of GDP for the last 10 years or so. Now you might say, very properly, I'm surprised that nobody jumps at me, but Japan, they've just had the lost decade. You know, clearly this R&D has done them no favours. That's true.
Or alternatively, the R&D is being flat.
Wait a minute, I've got it in stereo here. David.
Yeah, alternatively, Japan, I don't know what GDP's done. If GDP's gone down and R&D's been stable, as a percentage would go up.
No, GDP hasn't gone down in Japan, they're growing, everybody's growing. You know, it's not difficult to get some kind of growth. But what were you?
I was just, the same kind of thing, but just the rate, if the rate of the graph is moving and one's not changing, the other is, then you'd still get a shift like that, but I don't know.
No, I think there's a deeper point. No,
No,
there's a deeper point here. GDP has been growing in Japan, R&D has been growing faster. The deeper point is, you can't determine that R&D will necessarily solve economic problems. But you can say that if you don't do any R&D, you're definitely, in a mess. Einstein said, or he's supposed to have said, if we knew what we were doing, it wouldn't be called research. So that brings out the unpredictable and inherently unpredictable nature of research. That if you could predict the outcome, then you're not exploring, you're not discovering, you're not making things new. And this is a big defect in Lord Dreyson's policy for British universities of research and development, which is all meant to establish certain new labour tick box outcomes, targets, to make us number one in biotechnology in the world. Well, you can't assure that by focusing tons of money on biotechnology. There's no guarantee of that at all. However, if you fut around like this, there is a guarantee you're going to be in a mess. And in this respect, therefore, there's no right level of R&D intensity. It's not 10% or 20% or 30%. But it's a broader question than simply economics, which is, what are your politics? Do you believe that a focused goal with real inspiration and real curiosity, collective work, hard work, with proper technical skills, where 2 and 2 always equals 4, and you do not give any toleration to the youth perspective of whatever, 2 and 2, well, it might be 5, whatever, 3 maybe. But you really go after stuff in a focused way. Yes, sir?
Sorry, what's the line between Japan and the
OECD.
between the OECD and Japan?
That's États-Unis, I'm sorry, it's in French, it being the
Yeah.
OECD.
The United States.
Yeah, United States, yeah.
Hence why the letters are backwards as well.
Yeah.
Yeah, they're French.
Now, these proportions are rather important. Obama has just declared $2.5 billion worth of support for electric cars in the United States. That's good news. Before we rush to applaud him, you need to set that against, say, the defence research and development expenditure in the United States. And broadly, we can talk about it, ambitions with the Obama regime until that point with electric cars have been very modest, very modest. It's all in the book. Here's the more nervous-making picture, which is what's happened to government, which you might expect, which is that, again with the exception of Japan, sort of stagnating a bit, there's been a precipitate decline, and here we're talking about fractions of 1%, especially in the United States, also in the EU 27. Government is just not doing research and development the way that it used to. Now this is not nostalgic, it's just a fact, and it's a worrying fact because, go on.
Sorry, I'm saying, well, possibly government is doing research and development as it used to, it just hasn't got any bigger, while the economy has.
Yeah,
They just
that's...
putting along doing their NASA thing
Yeah.
or whatever.
Is that United States drop in defence R&D?
Defence is pretty buoyant, actually, especially since 9/11.
I would have expected US defence spending to drop quite dramatically after 1989, which is what that seems to be showing between 89 and 98. So.
Well, the famous peace dividend from the Cold War really didn't diminish R&D in defence in the United States very much. And most of the R&D is actually conducted by the private sector in the US. Right? So when you're looking at these government-picked stats, yes, there's Los Alamos and various national laboratories and so on. But most of it is done by, in the previous chart, businesses.
I understand that. It's just the percentage drop in that
Yeah.
particular chart.
Well, it's a good question. I'd have to look at it more closely, but if you look at the broad picture on defence, it has still enjoyed quite a large, munificent budget for R&D in the United States for the last 20 or 30 years. Those things don't change. What has changed is that national laboratories to do with weather and oceanography and all kinds of things that are not quite as sexy as missiles and so on, that has been privatised broadly, certainly in the British case.
A lot of government R&D is classified, especially in United States and China. So how do we know that how do they back up these numbers?
Well, that's a good point too. The fact that it's classified doesn't mean that they're not tracking expenditure on it. Whether this is the full
They're saying this
defence.
is what we're spending, but they're not saying what they're spending it on.
Yeah,
Right.
well, they will say
Yeah.
it's defence expenditure. Obviously, how true the figures are is a problem in civilian economics, especially with China's GDP recently, which has been criticised by the Chinese authorities. But no, this is only a broad picture. But I think when you look at these numbers, I mean, maybe it's not 0.26%, maybe it's 0.44%, but it's still less than 1% is being done by government. So, the issue is, do we have the confidence, the vision, the belief, the leaders, the trained scientists and technologists to really change this? And I think we have to do, it's not, as I say, it's not just an economic question. It's also a historical and cultural question. Why are we so risk averse? Why do we not want to take steps that could bring problems. Technology always brings